Hello everyone, my name is Praveen. I welcome you all to your own YouTube channel Java Fun. We are continuing with our Docker series, and this is the second lecture in the series. If you haven't gone through the first lecture, please go through it. It's available there in the playlist. In the first lecture, we talked about what exactly is Docker, what is containers, what is virtualization, and what are the technologies or what are the concepts on which Docker is based on. And now, in this particular lecture, we'll go in deep about how exactly the Docker is working, right? So, what is the theory or the concepts which are underpinning the Docker? Now, in typical day to day working, when you're using Docker, you may not need to be aware of these concepts, but it's always better to know the technology which is powering your tool set, right? So, without spending much time, we'll go through that thing and we'll see how Docker is working. In terms of Dockers, right, and the virtualization, we briefly touched upon the namespaces, and we talked about namespaces. We can think of in a layman term as a compartments or the segments created by using virtualization or by using containers. Now, the second new term which has been coming here is control groups. Now, we haven't touched about control groups, and that is something we need to understand in. We haven't touched about control groups, and that is something we need to understand about. Now, let's see how it works. This particular diagram, which you are seeing onto your screen, is a typical architecture of how any particular software host works, right? Whether it's a Linux OS or anything. On the very top layer, that is depicted by your blue color. So you have different applications installed onto your guest OS. So for our example, I have talked about we have Chrome, Paint, Camera, any music app or whatever it is right now. That is a piece of software. Now that has been written into some higher order languages or anything. Now how those applications utilize the underlying resources. Now your resources are depicted into lower layer: CPU, memory, hard disk, IO, the music, audio, the screens, anything. So these are all your resources. So how your application basically get use of these particular resources? So that is been achieved by a kernel, right? Now, kernel is nothing but is a piece of software which is directly responsible for utilizing your resources. Now, your application basically makes a call to a kernel, and kernel then in turn makes a call to your resources. Now, this is how it works. Now, suppose an example or a scenario wherein I have an application A and application B, and now they want to utilize or they want to execute a certain piece of code using a language. Let's say, for our example, let's say Java. Java basically comes with multiple versions, right? Now, let's see, and just for the hypothetical reason, let's see now application 1 needs Java 8 and application 2 needs, let's say, Java 11, right? And they're not backward compatible, and then you cannot really utilize any other version of Java. So I'm completely making it up as of now just to illustrate a point to you. And uh, if your OS, let's say, is only compatible to execute or install a Java 11 version. Now, how your application 1 will work in this particular scenario on your host? That is not possible, right? Because application 1 cannot work on, let's say, Java 11. That is not compatible. So in this particular scenario, you have a dilemma, right? Your two applications, they are not compatible. They need to use two different versions of a particular software, and on your OS you are only able to install a one version of a software, so other application cannot really work. Now if you want to achieve such kind of scenarios, how you going to achieve it? How you going to basically make sure that both the application 1 and the application works, run simultaneously on the same machine, and they should execute perfectly fine without any software version conflicts, right? Now, at here, your namespaces comes into picture. Now, as we told earlier to you, even in the first lecture that you need to create something called as a compartments or a segments, right? And now those segments basically will be hosting a particular version of a software's dependencies, settings, you name it, it will have it, right? You still have a similar kind of a thing on, but in your hard disk or in your resources, now I created two different segments. On one segment, I installed Java 8. On another segment, I installed Java 11. Now, application 1 needs Java 8, application 2 needs Java 11. So, whenever they make a system call, kernel basically decides which segment to call. So, if the call is coming from application 1, it basically utilizes or makes a call to segment which is having a Java 8 version. If the system call is coming from application 2, it makes a call to segment 2 and to a which is having a Java 11 version installed onto it, right? Now this segments, compartments, whatever you call it, it is nothing but a namespace. So you are basically isolating two different areas within your hard disk, and it is not only confined with hard disk, right? It is a hard disk, memory, CPU, any resourcing that we have in your house. Those can be compartmentalized. Now, when you compartmentalize your namespace, how will you decide that which compartment can utilize how much of memory, how much of hard disk, how much of CPU, who will govern that particular thing? Now that is where your control groups comes into picture. So now what control groups are doing? Control groups are basically limiting the amount of resources per process can use or per application can use. Namespaces, as we told you, it is isolating the resources, and the control groups are basically limiting the usage of those resources. So any resourcing that we have, your IO, input output, CPU, memory, hard disk, network, audio, whatever it is, right? You basically limiting the usage of those particular resources. Namespacing is isolating those resources together, right? So that on one physical machine, I can create number of segments, number of namespaces, and I run a different OS, different applications, different everything, whatever I want, right? In a one particular machine, and without conflicting with any other machine, right? So that is what we wanted to achieve, and that is where Docker comes into picture. Namespacing is a concept which is very native to Linux or the Unix like operating systems. On basically Linux like machines, namespacing was there from day one, and how it has been implemented, right? This is the philosophy that they come up with. So your one process basically running into all these boxes that you're seeing, box 1, 2, 3, running process basically running into their own namespace, talking to the Linux kernel, and internally it is talking to your virtual machine and all those things, right? If you want to have this kind of a thing onto Windows machines, basically what you need to do is you need to install a Linux virtual machine on top of your Mac OS or Windows, because the concept of namespaces is not native to these particular OSs, so they don't really support the namespacing and all those things, right? So whenever you are wanted to create a containerization or the namespacing kind of a thing, you need to run a Linux Linux OS or Linux virtual machine on top of it. So that's why any containers that you create as part of Docker, it has to be executed into Linux like environment. It cannot be executed in a Windows or a Mac OS, any like that, right? So it may be Ubuntu, Fedora, Linux, CentOS, whatever it is, but it has to be a Linux like environment. It cannot be executed into Windows or Mac OS. So that's a very important thing that you need to keep in mind. So whenever you create a containers out of your code, you need to provide a Linux OS runtime to it. Then only your Docker containers will work. That's the most important takeaway from this particular lecture, right? Now, in the last lecture, we talked about what are the virtualizations and what are the containers. So we'll again briefly go through it. In this particular diagram, if you can see, you have a server, which is your hardware. So both of these containers and the VMs has a server. So they both have an hardware. They have an OS installed on top of it. So the last two layers or the first two layers are common in these two things, but after that, in case of VM, you have a hypervisor installed. So hypervisor, as I told you, is a software installed on an OS or on a hardware directly, which gives you the ability to compartmentalize, create the namespaces, virtualization, right? So on top of those hardware hypervisor, then you install again another OS, which is your guest OS. Now the guest OS can be Windows, can be Mac, can be Linux, can be something else, right? Now those OS, they have their own binaries, have their own applications. Compartments are fully isolated. The only thing which is common with them is an underlying hardware, right? So one compartment is really not aware of anything else. So this is your VM, right? Your binaries and everything is all separate. But in case of containers, if you see, instead of hypervisor, we are installing a Docker engine, which is a software again, enabling you to create a compartment. So the namespaces. But the fundamental difference between the VMs and the containers is that the underlying binaries are shared between your containers. Unlike VMs, where they have their own versions and the copy of their own binaries, right? Libs, everything. Here, the bins, the binaries, and the libraries are basically shared. So that's the most important thing. So that's why the boot up time of container is very, very fast compared to VM, because it has to boot up everything right from the start. And the memory requirements will be large, which is understandable because these have their own isolated things, and these are all segregated out, right? So that's the difference between your containers and the VMs. Containers are isolated, but they share the OS, they share the hardware, they share the binaries and the libraries. On a very, very high level, this is how the Docker architecture looks like. And in the next lecture, in the next lecture and the lecture after that, we're gonna see how it works, right? So when you install a Docker, it comes with a Docker daemon, the middle box, and you have something called as Docker client. Docker client is nothing but a terminal on which you are running your commands, any of the Docker commands. So as of now, forget about what is build, pull, and run, right? So just think of it as just one command that you're executing from your command prompt. When you execute this particular command, it basically makes a call which is listened by your Docker daemon, and Docker daemon is responsible for taking an appropriate action on top of that call. So what is containers, what is images, all those things will come into due course in this particular lecture. As of now, just think of these two things. You have Docker CLI, client interface, separate. Docker daemon, think of it as a server, think of it as a client server kind of a relationship. Client is separate, server is separate, right? The third thing which is coming into this particular thing is a registry. If I want to give an analogy, think of it like a Maven repo. It's a Maven equivalent of it's a repo equivalent of what you see in Maven, exactly the same thing that you see in Docker, right? So you push something, you deploy something into a repo, and anyone, provided they have a repo URL, can fetch your jar or whatever it is. In case of Docker, is a container or an image. They pull it and then execute it. So registry is something similar. As of now, I think that that much is enough. When we go and start coding, this thing will be much clearer for you. That's it from this particular lecture. In a recap, we talked about how the typical OS architecture is, the problem of maintaining multiple versions, how to create namespaces, what exactly is the control groups, what control groups does, how the namespacing works in the Windows like machines, because namespacing is not native to Windows, Mac OS. If you want to achieve that, what needs to be done? What is hypervisor? What are the containers? What is the VM? And what is the high level architecture of Docker, right? So those are the things that we talked about. So that's bring us to an end of this particular lecture. In the next lecture, we're going to talk about play with Docker, our very first Docker tutorial. much of like an hello world kind of a tutorial, right? That is something that we're gonna do in the next lecture. So stay tuned. If you enjoyed the lecture till now, please go ahead and subscribe it. Most importantly, press the bell icon, without which you're gonna not get a new notification whenever I add a new videos. If you haven't seen my earlier videos playlist, go ahead and look at it into the channel, right? Uh, Again, don't be lazy. Go ahead and subscribe it. Your subscription is the motivation for a YouTuber like me. Uh, so that's bring us to an end of this particular lecture. Thanks for tuning in. Thank you so much.